Welcome to another episode of Out of Spec Renew. I'm Dave and I'm at the Everything Electric event in the Sydney Showgrounds. So that's the rebranding of Fully Charged live series of shows. I didn't want to just do a tour of the show because although there's a few interesting things, well, a lot of interesting things, right? Anyone watching this channel has probably been to one of these events or is familiar with most of these products. So, and Australia, look, honestly, is a bit of a backwater in terms of EVs. We sometimes get models that have been out overseas for a long time. But there's one very interesting thing here, which I wanted to go in detail on. And it doesn't have 2 wheels and it doesn't have 4 wheels. I think it has 10 wheels. And that's a very uniquely Australian product, which is the Janus Electric prime mover conversion. So these are full-size semi-trucks, we'd call them in Australia. But this Kenworth, for example, that can pull up to 200 tonnes of road train. That's, multiple trailers that we have in the outback in Australia. And these are conversions of existing trucks. So full conversion system with motor, transmission in the front, and the craziest innovation of all, removable and swappable battery packs. I'm going to talk to the chief engineer behind all this in a second, and he'll go through all the technical details of this, but basically imagine 600 kilowatt hours of battery pack that can be swapped for something like Cement Australia, where they can be running a fleet of these and be in and out in 5 minutes with a brand new fully charged battery pack. No chargers at all on board, all off-board charging in these 2-tonne battery pack modules. Inside this electrical junction box is all the 12-volt control wiring, and that means everything connected to all the sensors, the motors, the batteries, the thermistors, all of these kinds of things that are giving every parameter of the vehicle, then into a little PC, then into a little 5G modem, so that all that data can be sent every 10 seconds back to their headquarters. Really, when they're 25 vehicles in, they're still putting development miles on these cars, and having all that data, having all that logged as well for insurance purposes, should anything go wrong, is really, really powerful. And I'm always jealous of the space that they have available in a truck like this compared to when we're working on a small vehicle like a Mini, where we're struggling to find space to put anything.
Lawrence Ambrose, head engineer over at Janus Electric, and this is a Kenworth 403 that we have converted to electric, pulled out the old diesel and replaced it with fully electric, replaced all the ancillary equipment with electric equipment, and everything runs off the 750 volt battery that we have on board.
Cool. So Kenworth, if you can explain to an international audience, is built. These are built here trucks, and
they're assembled here in Australia, but they're owned by PACCAR, which is an American company. This truck would be 12 years old, thereabouts, and done 1 million kilometres. And when they get to the end of their sort of first initial major overall, that's when we're trying to target trucks to come across and be electrified.
Cool. So then this is a system that's designed specifically for this model Kenworth, or it's core tech that can
be? Generic system. We've worked very hard to be able to convert most electric trucks. At the moment we've done bonneted trucks mainly. We do have a cab over truck running around. Battery location is a little bit different because of the shorter wheelbase on the cab overs, and that's one of our challenges at the moment is trying to select trucks that have the right wheelbase to be able to put our battery system in between them.
So we'll get into that because I think the battery system is the key innovation here. But I can see a lot of orange cabling going into an electrical cabinet there. What's going on in the back there? And maybe let's go and have a look at it.
Yep. So that is our main distribution cabinet, where we bring our high voltage from the batteries into the truck, and we do our switching in that cabinet. So we've got battery on each side of the truck. Each battery has 3 modules in it, for a total of 6 modules, 750 volt nominal battery. And then all the cabling comes up into the top.
Yeah, pull out. So when you say the battery pack, this is how many kilowatt hours in each side, and what's the weight of that?
300 kilowatt hours, total of 2 tonnes each side. 300 kilowatts each side, 2 tonne. So a total of 600 kilowatt hours. And as batteries change, we can quite simply change the chemistry inside the battery. The form factor will stay the same, and we can just swap what goes on inside the battery. So we've given that a lot of thought in the design to be able to work out how best can we future-proof the battery. So as the technology of batteries increase, we can then upgrade what goes inside the
And
batteries.
so maybe I'm just looking here at the framework of everything. It's kind of, you've got the luxury. I think whenever we deal a lot with Land Rovers, and
Yes.
they are essentially a 1940s, 50s commercial vehicle with lots of squares and right angles. But
Yep.
you've also got, I want to call it the luxury here of massive, strong frame rails where you can bolt 2 tons to.
Exactly right. So the rails of the vehicle we don't touch. We don't reinforce them. We've looked at it, analysed it, and we were able to bolt the battery packs on. We've done some things to reduce the moments going into it and reduce the stress on the frame. So if you have a look here, we've got a big bearing in between the battery frame and the actual chassis that stops a moment being transferred into the chassis or into the structure, either way. And yeah, it's just one of the things that we've been very conscious about. How do we interact with existing chassis? Now, the good thing about trucks or prime movers of this size is that the rails are pretty much the same size, give or take a few millimetres. There are a couple of brands that are slightly narrower, but because of that, we're able to take these frames and pretty much bolt them onto any existing prime mover.
So you mentioned that as battery technology changes and improves, you can change the batteries over and get more energy, perhaps lighter, whatever you want to be. But it's not, these batteries, the secret is not that you can change them after 5 or 10 years of operation, it's that you can change them every day, right?
So we got, it's a swappable battery, a couple of forklift tines, come in, pick it up. It's got some locks on the inside. As the tines come in, they unlock the locks, battery comes up, comes out, and then we can drive it around, put it in our charge station. So the way we've designed our charge stations as well, that there's always an empty bay. So on the charge stations, we've got 2 bays. One will be empty, one will have the batteries in, so you never have to put the battery down on the ground. It's never double handling. You pick it up out of the truck, put it in the charge station, take the other side, put it in the charge station, come back, pick up the new battery, 2 halves, and go in. Now the batteries are matched.
Yeah. Sorry, we'll get back to that. So I'm just
Sure.
looking at it here mechanically.
Yes.
This is the battery pack, and
That's
then
right.
this is the frame that holds it. So when it's on the forklift through these tines,
Yep.
it lifts up to this point. That gives it the clearance over the base.
That's right.
And then it can come out.
Come out. So the whole idea of when designing the battery frame was to be able to have the battery well secured, and by dropping it down, we're able to secure it a lot easier than have big locks and everything hold it in. Because really what I've got to do now is stop it coming up. And to stop the battery coming up is a fairly easy process with the locks that we've custom designed. And yeah.
And so when that comes in, and we can see the orange cabling coming in
Sure.
to here.
Yeah.
And then, so that is like you said, the forklift just comes in. The operator doesn't have to go and plug anything in.
No plugs. It's all incorporated. So just the fact that the battery, we've got it to align, comes in. A couple of things that taper, center the whole battery, and then it just comes in, makes contact with the connector. Connectors come in, and then they drop. So the whole connector plug, which is integrated into the operation of inserting the battery, just moves with the battery once it goes in.
Cool. So there's no active cooling, there's no coolant lines then going through the packs?
There isn't. No, our batteries, because we're pulling maximum of 540 kilowatts, that's the size of the motor. It's a 600 kilowatt hour battery.
Yeah.
You're never pulling more than 0.8 of a C, and that's only a very short period of time. Because we're not drawing that much power, we don't have the temperature rise that you would have, say, in like a Tesla, where you're pulling up to 6 to 8 C.
Yeah.
And because of that, we don't need the additional glycol cooling. We do have internal fins, and we do have we do move the air around inside to be able to push that heat from the cells that we do generate back into the sidewalls, and just natural, or when the truck's driving down the road, that's enough airflow to be able to cool it.
Now you mentioned that the batteries, obviously there's 2 battery packs essentially, one on each side of the vehicle, and that they of course need to be matched.
Yes.
From an electrical point of view.
So that's right. And the 2 batteries, so you'll see here they both got the serial number. So that's battery 18B. And if you go to the other side, that'll be 18A. And they inside the 2 batteries, we've got electronics, and we've got certain addresses, and we're able to, the batteries will not connect unless they've got the matched pair in them. So the first thing they go through before the contactors come in is the computer on board will read from the BMSs and identify that they are the same matched battery, before they engage. When we build them in packs and build them in halves, so they are married from the workshop. But should we have to, say we have a problem on side A, and B is still fine, and we have another pack from another battery that also gives us problems, we can match them out in the field. A bit of programming, we can match them, so then we can recreate the pair.
And I've seen some behind the scenes stuff, and because we build battery packs in our workshop of much a tenth of the size of this.
Yes.
But, we use Orion BMSs, and I've seen you guys perhaps using Orion BMSs
Yes.
and things like this.
So in each battery we've got three Orion BMSs in each half. Total of six Orion BMSs, and because we're running 6, we've heavily integrated with the Orion pack, especially from a control system.
And that's why I see a number of, there's a lot of orange cable. There's not just a positive and negative, like you said. There's 3.
Yeah.
There's sort of 3 battery packs in that, or that's how
in
it's
each
seen.
half,
It's just an
yes.
enclosure that.
Yes. So we've got three packs on each half, so 6 packs in total. That's 12 orange cables coming up into the distribution cabinet, but then we've also got cables going back out to the front. So we're
So as it comes into here, maybe if you can just explain
Sure.
that, so that you've kind of got 6 positive, 6 negative coming into here,
Yep.
and then essentially, I'm assuming, coming together and then spitting out, the
Correct.
final battery voltage.
Correct. So we've got a common bus bar inside the battery pack, but we've also got things like a pre-charge circuit. We've got our auxiliaries, the water pump. So it's a water-cooled electric motor. So we've still got a water pump for that. The air conditioner's its own circuit. We've got the 750 volt to 12 volt inverter. That's a separate. We've got a combined inverter where we have an air compressor, the charger, and there's one other power steering pump.
Yes.
Those three inverters all combined into one power supply.
So you mentioned charger.
Yes.
And you've got a swappable battery pack, but you're not always near a swappable batty station. So
Right.
do you have an onboard charger?
No, we do not. No. The whole concept is no onboard charging. It is only a swap and go swap system.
Because plugging it into your PowerPoint for what, like 3 weeks?
Well, that's right. And even the 600 kilowatt hours, the amount of power that you need to doing that, we're looking at 400 amps in 3-phase to be able to get what we need there.
Yeah. So maybe let's talk about then the powertrain. So I think that people might have seen, there's a lot of OEMs, automotive OEMs, pushing renders, let's say, of electronic axles, motors on axles, and you see it in a few of the commercial vehicles that are here.
Yep.
That's not what you guys did.
No, we don't. We've looked at it and said, all right, well, where's the diesel engine? Where's the gearbox? How can we try and simulate, because we're doing a rebuild and a conversion, we want to try and load the chassis up in exactly the same way as it was previously.
So let's have a look.
If we're once you start steering away from the way a diesel puts load into the chassis, we feel you're going to run into other problems. And so what we've done is we created this framework inside here, which is called our Janus conversion module. Now inside that Janus conversion module, we have a 540 kilowatt motor on the front, and then a 16-speed gearbox, which sits inside that tube. And the whole premise there is that it ends where your diesel would have ended, and the diesel then's got your engine mounts going into the frame. We have not changed that location. Keep loading the chassis up in the same place. You're going to get the same longevity out as what you do out of a diesel. The reason why we had to move everything forward was to make room for the batteries, which does mean we extend the drive shaft.
So when you say this fits where the engine finished, but that means the motor and transmission finish
That's right.
Yes, at a more forward.
That's right. So, and that's why we've got this big torque tube to be able to get back to the same place as where so we're using the same location of where the original diesel mounts go, where our electric motor mounts go in the same place, which is then on the JCM. Now included in the JCM is the inverter, so that's our combined inverter. That's our air compressor, all running off the electric.
I noticed it's a dual core motor. I noticed multiple of three phases, or 2 3 phases. Sorry, going into that.
So we use a Dana a Dana motor, or originally was a TM4, and they've joined up together. 540 kilowatts, 2,600 newton meters of torque, and so it's. I won't get into too much technical detail about the motor, but essentially it's still a DC motor, but with the 6 phases.
And you do, and it's really, is it as much that you're using 2 inverters to be able to deliver all that energy to it?
So we still only use the 1 inverter. The second inverter is for the ancillaries. So if we come around in here, we can see that you've got these 4 wires over here, or the power coming into the inverter. And if we go around the other side, you'll be able to see, you've got three cables coming out, going into the electric motor from the inverter, and on the other side here, that's probably a better view, we've got another 3 coming out into the electric motor. So it's still a single inverter with 1 set of control on it, and both the inverter and the motor are designed together by Dana, work together, function together.
Now you said a lot of people think that EVs, I mean, maybe they think that they will consider they have a reduction gear. Some EVs, Porsche Taycan, for example, has 2 gears. You said you've got 16.
Yes.
Is that sounds like as many as a normal diesel truck would have?
That is, and the reason why we've done that is because we haven't redesigned the gearbox. We've used something that's standard in the industry, that the industry can rely on. They know the distance they get out of it. And from an engineering sense, it makes sense to use something that's existing and try and interact with it. Is it the most effective way to do it? Where we are at the moment, yes. Could you engineer something better? Absolutely. But that takes time, money, and we started this company in 2019, and currently we're building truck number 25. So we believe we're doing the right things to get trucks out on the road. But having said that, there is more that we could do on the engineering side.
Hello, mate.
Good day.
And I think that would be an element of, more speeds allows you to keep the motor in its prime sort of efficiency band as well.
Exactly right. Yes.
So, you said you're up to truck 25, which we see battery pack 18 on this one. I think that, I think that's one of the amazing things, being in the small scale electrification game in Australia myself. We don't have that luxury of go away and do R&D for however many years. Exactly. We need to get product out the door and revenue into the business.
That's right. So you've got to be seen to evolving at the same time to be able to generate that revenue.
And how do you feel that has been with has using an existing truck? And I say this coming from this perspective as we're sort of standing on the shoulders of classic vehicles. Working with an existing truck and a known brand like Kenworth, like knowing operators know how to drive them, everything's familiar. Has that made the transition easier for people?
It has. There is definitely, from the client's perspective, if they can use something that is known and they can get the reliability out of it. Obviously, we're doing a lot of modifications and a lot of, but the existing stuff, try and use what you can where it is known in the industry, and that gives them some confidence. But all the clients that we've worked with thus far, very, very understanding that we might miss a gear shift here or there, but that's not the end of the world to them.
But there'd be no one's questioning other aspects of the vehicle. They're not questioning the axle load. They're not questioning the couplings. These are all super familiar, so they can put them to work.
Exactly right. And especially if you've got a truck that's nearing its major service. And within a month you get the conversion done and the truck's back on the road and you've gone from diesel to electric, is another thing that we've really concentrated on hard to be able to get that conversion as quickly as possible.
And I've seen reference to you guys pricing around $150,000. I don't know if that's correct or not, but I imagine that any EV conversion is expensive and really is honestly about a similar price. But I was guessing when I heard that number that you don't own the batteries for that price.
Correct. So at the end of the day, anybody can own a truck, anybody can own a battery, anybody can own a charge station, and the idea there is to try and make it as scalable as possible. And if you have an interest in owning a battery, by all means you can purchase a battery, and then you get revenue back on that battery. And we have a pay per kilometre, pay per kilowatt hour going in and out of the battery that the owner of the truck pays for, and then that can come back to the owner of the battery.
So I see big Cement Australia branding there behind you.
Sure.
I'm assuming this is then a working truck.
That's correct. Yeah. So this is we've done 6 for them, and they've just recently placed an order for more. So you'll be seeing a lot more Cement Australia trucks with the green bonnet out on the roads. Typically they'll be out of Melbourne.
Cool. Can you describe how does that? I mean, most people aren't familiar with the logistics of running a trucking fleet, a cement moving trucking fleet. How does this? What's their day to day with these? Are they like the frequency of swapping batteries? How does it work?
Yeah, so because they're back to base and they do a lot of routes in and around Melbourne, they don't actually swap the battery that often. It's about every second day that they swap the battery on a typical truck. A lot of their time is the truck pulling up to a cement works to be able to blow out the powder, and they blow the powder out using a blower that's on the back of the truck, still off the 750 volt battery. So if we come around here, we can see here that is the blower, and it's running off the same battery. So the truck with its load pulls up to the cement works and is able to blow out the powder. And so a lot of the time, it takes a couple of hours to discharge it.
As chief engineer, what's your favourite bit? What are you most? What was the? I guess what left you scratching your head late at night? What is the wee little innovation that you've done in here that you like that perhaps we wouldn't notice at first?
Yeah, first up the locking mechanisms on the battery. That took a while, but we've got it to a point now. It's really, really simple. It unlocks with the fork tines, and the whole concept of being able to keep the load path the same with the JCM where it is. That was another, real good feeling, being able to work that out, get it in the truck, and have something that can be put in as a replacement for a crate motor.
How has it been from a regulatory point of view?
Yeah, it's had its challenges, but we've ticked every box, and we work with them. But it's because the trucks already have been registered. There's a lot of things that have been ticked off by the OEM, which we don't need to go through. So we're only jumping through the hoops that are relevant to our modification.
In the interior, I'm looking in there and I'm seeing a very traditional. You said the truck was 12 years old, but I look in here and it also feels like the 1970s a little bit. That's my ignorance of trucking world. The seats look nicer.
Yes.
But there's a lot of leather and wood grain.
Yes.
What additional instrumentation and gauges are you giving to the operators?
So what we've done is we've removed quite a few of the dials and gauges, purely because they're irrelevant. Turbo timer or the turbo timer. In this case, the turbo timer's still in there. We've just disabled it. But there's a lot of gauges we removed, and then we've added a screen. Now the screen we've added isn't the most modern looking screen either, but it's something that we can interact with, and we were able to display a lot of information on there that's relevant, and then customise the screen to be able to interact.
And that, I mean, I imagine there's a lot of. If you're operating one of these vehicles, you would, my gut feel would be that driver, that operator, is also probably a pretty proficient diesel mechanic of sorts.
Yeah.
And does there a bit of a there's kind of less to know, but it's completely different at the same time. How's the transition for the drivers been?
Yeah. So I mean, you might think that most truck drivers are mechanics as well. Not so much when you're working for a larger company. They are drivers. They're not actually that technically savvy. But then you've got your old school drivers who really don't understand electronics at all. And interacting with the screen itself, and it's a touch screen, it can be challenging for them. And in that regards, keeping it simple and using something that isn't the most modern looking thing has, I think, aided with that regards. But then you do get your keen truck driver who is all up to date on latest what's electric, and then they want to know everything they can as much as they possibly can. In that case, we've just got to pull back and say, listen here guys, this is 750 volts.
Yep.
You can't just be touching it, you can't be going in. And that's why if you have a look at our cabinets, all our cabinets have got physical key locks on them, not just a lock that anybody can get into, to be able to keep out people, because at the end of the day, electricity can be harmful if not treated right.
I mean, we know from experience, dealing with old classic cars, that maintenance is on the classic car part, not on the EV part.
Yeah.
So I'm assuming you're giving battery voltage, state of charge, you're giving temperature, you're giving motor temperature and a few things like that.
Yep.
But really it's to give everyone peace of mind that you are monitoring these things, because I don't imagine there's much to, like you said, the C rating is so low.
Yeah.
What's going to change?
Sure. And then on the screen, we've got a couple of ways of getting into the engineering screens, which gives us some more access to information. And that's there if we do need to, if there is a problem on the side of the road, that we can get a bit more information out of it. But it really happens.
And that on that is, I'm a driver. I pull up. I'm getting I know that I've done this many kilometres. I'm getting a low state of charge. I pull up. I get the battery swap. Do I have to do anything as a driver after that happens?
No. So it's fully integrated. Key off to be able to pull the battery off. Pull the battery out. Key off. Come down. Climb in the forklift. Pull the battery out. Put a new one in. Climb back in, key on again, and the truck.
And you've got a matched pair of Orion BMSs that are spitting out a state of charge signal, and then it's through other stuff. I'm sure.
Well, because we've got the 6 on our engineering screen, we can go through and have a look at all 6. But we've also written some code to be able to interpret that, because if you had one saying it's at 40% and one's at 60%, well, obviously that can't work. And we go through, and we've got some checks and balances in place to be able to look at the.
And is that, from an electrical point of view, is this 750 volts when they're all in series?
No.
Or can you drop a cell, or can you run with just one pack?
Yep. Depends on what you're pulling, but we can definitely drop up to 2 packs without any detriment to the performance of the truck. Once you start dropping more than that, then you've got a bigger problem. But yeah, which means that if a pack really gets low, and it's always based on the lowest cell, so if a pack gets low, drops out that pack, you can still keep going, drops out that pack. So it's 6 packs in parallel and 175 cells in series per pack.
Cool. Now you said on weight, you said 2 tonnes total. This was obviously where the fuel tanks were, which were never small in these anyway, but you're probably denser than that now. What's this doing to
so
the
we add
overall
2
weight?
tonnes. We add 2 tonnes to the weight of the truck. And then the position of the battery determines how much weight we throw forward. And now we've also got some regulation changes from 6.5 tonne, provided the axles can handle it. And on these trucks here, we've upgraded the axles to 7.2 tonne axles. And on some trucks, we even go higher to be able to utilise the more weight on the steer, which means we've got a balance between low carrying weight that comes back onto the drive wheels and throwing weight forward from the load, as well as the additional 2 tonne that we've put on with the battery.
Cool. And I've seen footage of you guys. Australia has some. Actually, over Christmas, I went over to Perth and back.
Yeah.
You see a lot of road trains. You see some trucks that are bigger than maybe any trucks. I'm not a truck expert.
Yeah.
I don't see footage of trucks being bigger than that anywhere else in the world.
Yeah.
Are you guys pulling like 3, what we'd call them B doubles, B triples?
Yeah. So over our heaviest truck that we've done so far, or heaviest load, is 132 tonne, and that was down out at Port Augusta, and that was a trial pulling a copper concentrate from Carapatina mine down to Whyalla to the port, with a swap station in the middle. 132 tonne. There the trucks are rated to 90 k's an hour, and we were able to complete that. That was a trial.
Yeah.
And look, the weight-wise, what we can do, we're currently going to be trialling something around the 200 tonne, which will be 4 trailers. But those are trials that will be
16-speed transmission helps,
that's right,
doesn't it?
It does. And on those, they're that gearbox will be slightly different on those, because we're using the Volvo gearbox, which has a super creeper, which has a 30-to-1 ratio in low gear.
Cool. And it's quite not ironic, but it's lovely actually that you're hauling copper in a way that's probably destined. You're probably buying that back in cell modules at some point.
Yes. The amount of copper that goes into the batteries and the copper cabling on these trucks is phenomenal.
It's phenomenal. Yeah. Well, awesome job. What's coming up this year on truck 25? Are you ramping up in that delivery or?
Yeah, and always, we're looking at growing as any company is, and we just we're in the middle of doing a raise, and looking at new premises to be able to expand and get more open up our lines, and then who knows, the sky's the limit.
It's amazing work. Thank you so much.
Not a problem.
Cheers.
Thanks, Dave.
Okay, so I could talk all day about this and some of the really interesting engineering choices that are going on inside there, because a lot of the componentry is stuff that we're using too in our much smaller conversions. Because we've got the same supply chain in Australia, or we're dealing with industrial electrical, or we're dealing with just conversions themselves and how to run high voltage cabling around a ladder frame chassis. I'm really excited to see where these guys take it in terms of optimizing the system. There's a lot of parts on there that are what was available to them at the time, or what they could get at a reasonable price for the scale that they're operating. But as this grows and this becomes a bit more refined and efficient, I think it'll look amazing in there, and they'll get better range and they'll get better performance. But I think they're going to do that in a really great way, and that is by literally getting things out in the world and having real feedback from owners, operators, drivers, because that is so different to building something in a clean precision workshop and then hoping you get it out on the road. These would be battle-tested systems that work in the field, and I think that's awesome.